Okay, this is part 2 of chapter 1, lesson 3, multiplying and dividing monomials. Now we are going to talk about finding a quotient of powers. Okay, quotient of powers, that means we are doing division problems. And the directions for that is to divide powers with the same base we are going to subtract the exponents. We are on example 4, which is on page 25. And the question given to us is 4 to the 8th over 4 squared. Remember, when something looks like a fraction, it's really a division problem. I'm going to stretch out the first couple to show you why this rule of subtracting exponent works. So if I draw 8 4s, right, being multiplied together. So 1, 2, 3, 4, 5, 6, 7, 8. And then I have 2 4s, 4 and 4. Off the page a little bit. There we go. All right, using what I know about fractions, right? 4 over 4 cancels out. This 4 over 4 cancels out because it's really just a 1. Well, once I've canceled out all the matching 4s, how many 4s do I have left? 1, 2, 3, 4, 5, 6. Using the subtracting exponents rule, I can rewrite it as 4 top minus bottom, right? 8 minus 2. And I end up with 4 to the 6th power. I get the same answer either way. This takes a lot less space, and it takes a lot less time. I'm going to move on to example 6, which has a lot more going on. 2 to the 5th times 3 to the 5th times 5 squared. So I have 3 separate bases here. I have a base of 2, a base of 3, and a base of 5. All over 2 squared times 3 to the 4th times 5. All right, first thing I'm going to do here, I don't see an exponent on that 5, so I'm going to add my little invisible 1. Helps me to keep track of it. I'm going to subtract these. If I were to write this all out, it would take up a lot of space. So what I'm going to do is I'm going to turn these into my little subtraction problems. This is 2, and then I've got 5 minus 2 times 3, 5 minus 4 times 5, 2 minus 1. Simplify what's inside of those little subtraction problems. This becomes 2 to the 3rd. This is 3 to the 1st, which you can write the 1, you cannot write the 1, doesn't matter to me. And this becomes 5 to the 1st. Once again, write the 1, don't write the 1, as long as you know it's there. Now the question is, can I simplify this? I think yes. This is definitely something you are able to simplify without the use of a calculator. 2 to the 3rd is 8 times 3 times 5. Use what you know. I'm going to do 8 times 3 first because that's 40, and 40 times 3 is 120. Remember, use the math facts that you know that are the easiest first. My rule in this class is if you can do it in your head, then you need to. If it would require the use of a calculator, meaning 3 to the 7th power, something along those lines, I'm not going to ask you to simplify that. You can express that using an exponent. I just realized I skipped example 5, so I'm going to go back and do example 5. Uses a variable n to the 9th over n to the 4th. Remember, this is a division problem, so I'm going to rewrite it with my little subtracting the exponents, 9 minus 4, and I get n to the 5th power. I don't want to forget my little parentheses there. Okay, I want you to pause the video again. You're going to take maybe 5 minutes, it should take you, to do D, E, F, G, H, and I, so all 6 of those example problems, before turning this back on and checking your answers. Okay, the answer to D is 5 to the 3rd. Now, do I simplify 5 to the 3rd? Yes, it is within a third power, and it is something that you should know. 5 times 5 is 25. 25 times another 5 is 125. So that one I would expect you to simplify. E, your correct answer is x to the 7th. Can't simplify that. I don't know what x is worth. F, I'm actually going to go through and do to make sure you did it correctly because it involves a coefficient. 12w to the 5th over 2w, and again, I'm just going to add that invisible 1. I'm going to separate this. I'm going to draw like kind of an invisible line through there because I've got 2 things I have to deal with. I have to simplify those coefficients, 12 over 2, and then I have to simplify the exponents. Well, 12 over 2 we know is equal to 6. And then w to the 5th minus the 1st is w to the 4th, okay? So don't forget that 12 over 2 needs to be simplified just like you would simplify a regular fraction. G, 3 squared times 5 times 7 squared. Should I simplify that? Well, 3 squared is 9. 9 times 5 I can do. But 7 squared is 49. 45 times 49, that involves double-digit multiplication, so Mrs. Bordewick is not going to make you do that problem any further than that. H. The correct answer is 5 squared, 7 squared, times 8. Again, this is the same as 25. This is the same as 49. That's double-digit multiplication. Mrs. Bordewick is not going to ask you to simplify that any further. I. Okay, my base is a -2, so that's why the -2 is in parentheses. When I subtract the exponents, I get a 3 times 3 to the 3rd times 5 to the 3rd. Well, right there, I know that 5 to the 3rd is 125, and that's going to involve double-digit multiplication, so Mrs. Bordewick is not going to make me simplify this any further. Okay, the remainder of your assignment today is to do guided practice, which is on page 26 in your textbook. You are going to do problems 3 through 6. You're going to upload a copy of that into Google Docs, and that will complete the requirements for today's remote learning assignment. If you have any questions about any of these example problems that we've done, please circle them in your notes, and I will answer your questions first thing tomorrow when we get to class.